Good morning, students. Today we are going to talk of queues in Python. That is, we would be implementing queues using Python programming language. Now, students, first we should understand what a queue is. We all have been in a queue in our life more than once. For example, if we have gone to a railway ticket counter, you might have seen that people stand one behind the other for taking the ticket. If you have gone to a bank, you will see for taking money, people stand in a queue, that is, in a line, one behind the other. So, what is a queue? We can well say that a queue is an arrangement where people stand in a line one after the other. And as I said, you'd have seen multiple examples of it to have written here. That is, people standing in a ticket counter or people standing in a counter of a bank. So these are state-of-art example of queue. And you all understand that there are some rules that are followed when you are standing in a queue. That is, you should follow some protocols while standing in a queue. You cannot enter the queue before a person. You should always enter a queue after all the person standing in the queue. That is, you should be behind. When you come after some person or say a group of people who is in a queue, you'll have to stand at the back of them. And who takes the ticket first? The person who is standing at the front of the queue takes the ticket back and goes away or leaves the queue at first. So these are few protocols which we follow normally in a queue. So let us now proceed. You can see this queue. Here 6 people are standing one after another, one behind another, and they are before a ticket counter. Now this is what we see normally, but as a Python programmer, we should have a different view. A Python program not only sees these people standing in a queue, he or she would think it in a different way. See how a Python programmer thinks about it. See, the Python programmer not only sees these people standing in the queue, it actually is seen as a list where people are standing in different subscript number. You can see that there is a 0 subscript number. We know in Python a list starts with a 0 subscript number, then 1, then 2, then 3, then 4, then 5. So all these things are subscript numbers. So a Python programmer sees a queue in the form of a list where people are standing in different subscript numbers. Let us proceed further. See how the Python programmer sees and understands that this sort of arrangement can be implemented using a list. So, what are the observations we have till now about a queue? The observation is that if somebody enters a queue, he has to enter behind all. He will enter at the rear end, that is, after all the people standing in the queue, that is, behind all the people who is standing in the queue. So, where someone enters a queue, the answer is at the back, that is rear end. Back is also known as rear. That is at the last. Now, if somebody wants to leave the queue, normally he would leave the queue after taking the ticket. Now, who is having the highest probability to take the ticket? Obviously, the person who is at the front. So if you are asked, who is going to leave the counter first? The answer is the person who is at the front leaves the counter first, and therefore we can say the queue first. So two observations. We insert in a queue as a Python programmer at the rear end, that is at the back, and we delete from a queue as a Python programmer from the front. So we can well see, while we were talking of stacks, we used to insert from the same end and delete from the same end. That is, we used to push from the same end and we used to pop from the same end. So I had to keep only one variable, top, to maintain it. But in queues, I have to take into consideration both the ends, the rear end also and the front end also. Rear end for insertion and the front end for deletion. Therefore, here we need two variables, that is rear as well as front, and both of them have to be maintained simultaneously. So I think you have understood that in queues, two given variables are to be maintained. One is rear and the other is front. While in stacks, only top used to be maintained. Why? Because there had been the same end which had to be used for popping as well as pushing in stacks. But in queues, we have two different ends for two different work. The front is used for deleting, while the rear is used for inserting. So students, I think you have understood how queue works. Let us proceed further. So as I have said, here Python programmer sees that deletion has to be done from front and insertion has to be done from rear. So he will take two variables and maintain two variables. These two variables are front and rear. So as Python programmers, we should also maintain two variables. One is front and the other one is rear, while we implement a queue using a list. Now students, suppose at this given moment our queue is empty. We have nothing in our queue. And we can well see that this queue is being maintained by us as a list. So this given list, which has 6 given places, is empty now. Our queue is empty. So as I said, I have to maintain two variables, front as well as rear. So what should be the value of front now? And what should be the value of rear at this given moment? Let us see. So at this given moment, to answer that question, we should first understand that who is at the front of the queue when the queue is empty? The answer is none. When the queue is empty, none is at the front of the queue, as well as none is at the end of the queue. So at this moment, if none are at the front of the queue and none are at the rear end of the queue, so mathematically, when we want to implement a list as a queue using Python, we'll have to write front as none and even rear also as none. Why? Because the queue is empty, none are at the front, none are at the rear. So no subscript number has to be given to front and rear now. We all know that front and rear keeps the subscript numbers. Front keeps the subscript number of the first man standing in the queue, and rear keeps the subscript number of the last man standing in the queue. So for a Python programmer, front keeps the subscript number of the first item or element kept in the queue, and rear keeps the subscript number of the last element that is kept in the queue. So when none are in the queue, front should be none and rear should be also equal to none. So again, when queue is empty, front should be none and rear should also be equal to none. Let us now fill some value in the queue. Let us fill some item in the queue. Now we all know that in this queue, items would be inserted 1 by 1. That is, the first item which comes would take 0th position. The second item which comes will take the 1 subscript number. Third item will take the 2 subscript numbers place. So that means 1 by 1 all these boxes will be filled, but the order of filling the boxes would be from 0th subscript number, then 1, then 2, then 3, then 4 in this given fashion. So let us now fill some value. See, this is a list with us. I want to fill some value. That means I want to do insertion. That is, we will insert value in the queue. Now, as I said, which subscript number will get the first item in the queue? You all know now. It is subscript number 0 that would get the value. Now, when subscript number 0 gets the value, what should be the value of front and rear now? That is just after the first subscript number gets a value. That is, one item is inserted. Yes, you all are correct, because subscript number 0 gets the value, so front as well as rear both should get 0, because that is the subscript number which contains the first record, that is first item, as well as when one item is only kept, that is the last given box which has an item now. So when there is only one item in our queue, that item is at the front, and at the same time that item is at the rear also, because we have one item. So front is also equal to 0 and rear is also equal to 0, because that given item is standing at the first, as well as being only the single item in this queue, it can be said to stand at the rear also. One item at the front even, as well as the same item at the rear even. So front is also 0 and rear is also 0. So I think you have understood here. Now if I am to insert one more item, so where should that item be inserted? Yes, it should be inserted at subscript number 1. So what should be the value of front then? Obviously, front should be 0, because 0 has the first value. And what should be the value of rear? Yes, rear should be 1. Why? The last value now after the second item has been inserted is kept at subscript number 1. So rear should be 1. So let us see. Inserting second item. So we want to insert second item. The first item has been inserted. So to insert second item, what should we do? What should be now the value of front and rear? See, we can well see that as the queue takes the second item at subscript number 1, and at this given moment, this is the last item, so rear should be made 1. But as the first item is in front, that is at subscript number 0, so front should be 0. So front should be 0 and rear should be 1. So this is what we have to do as a Python programmer also. We have to change rear to 1, but leave front as it is when the second item is being inserted, because the first item is in first subscript number and the second item, that is the last item at this given moment, is at subscript number 1. So front becomes 0, or I should say front continues to be 0 and rear now changes from 0 to 1. Let us now see how the rest of the items would be inserted and what should be the value of front and rear now. I think you can well guess that front will be 0 for even rest of the items, but rear will change. When the third item is inserted, rear will be 2. When the fourth item is inserted, rear will be 3. When the 5th item is inserted, rear will be 4. And when the 6th item is inserted, rear will be 5. So let us see, we have a table which we can see here to understand it. So this is the table. So when subscript number 2 is filled, that is, we insert a value in subscript number 2, then value of front would be as it is, that is 0, but rear will change from 1 to 2. When subscript number 3 is being used for insertion, if value is inserted in subscript number 3, front as it is 0, but rear becomes 3. When 4th subscript number is being used for insertion, front is 0, rear becomes 4. When 5th subscript number is used for insertion, that is, we are inserting the 6th value, front is again 0, but rear becomes 5. So this is how we need to maintain the front as well as rear while we are inserting value in a queue, which is being implemented as a list. So, what is the order of insertion in a queue? You can well see, initially we had front also none, rear also none when the queue were empty. But as item 1 gets inserted in subscript number 0, front becomes 0 and rear also becomes 0. When item number 2 is inserted, front remains 0 but rear becomes 1. When item number 3 is inserted, front remains 0 again but rear now becomes 2. Item number 4 is inserted as it is inserted in subscript number 3. Front remains 0 but rear has to be changed to 3. Now 5th item inserted. Now when 5th item inserted, front is equal to 0. And as the 5th item has been inserted in subscript number 4, rear becomes 4. Now 6th item inserted, front remains 0 but rear becomes 5. So this is the way how front and rear has to be maintained by a Python programmer also when he has to implement a queue using lists. And you can well see how items are inserted in a list which is being maintained as a queue. First index number 0 is used to insert, then 1, then 2, then index number 3, then index number 4, then index number 5, and in this fashion things can be inserted in a queue. So we can see that items are inserted at the back of the already existing item, that is at the rear end, one by one. Now let us see how items are deleted. See, we have the items. Item number 1 is in 0th subscript number, and we can see that item number 6, in which subscript number it is? Yes, it is in subscript number 5. So if something is being deleted, we have already said that if somebody has to go out of the queue or an item has to be deleted from a queue by a Python programmer, he has to delete the item at the front. That is, item 1 has to be deleted first. After item 1 is deleted, then item 2 would be deleted. After item 2, item 3 would be deleted. So here we need to understand that in lists which are being implemented as a queue, we always delete from the front. And as we delete from the front, the value of rear has to be changed. Let us see how. So we have to delete an item from the queue. So we'll have to observe the order of deletion. As I said, it should be deleted from the front. Let us start deleting it. So see, I am deleting item 1. So as I deleted item 1, now which is the item at the front? So item 2 is at the front. So what should be its subscript number? So its subscript number is 0 now because it is at the front. So if it is 0, then what is the subscript number of item 6? You can well see the subscript number of item 6 would be 4. So if I ask you at this moment, what is the value that rear should take? So you can well guess, as item number 6, which is at the back, that is which is at the rear end, has subscript number 4. So rear should take subscript number 4. So now as a Python programmer, we should change the value of rear to 4. Initially, when we started deleting, when item 1 was not deleted, rear had 5. But after deletion of item 1, when item 2 is at 0th subscript number, front will remain to be 0, but rear will now change to 4. Now let us delete item 2 also. So we delete item 2. Now which is at the 0th position, which is at the front at this moment? See, item 3 is at the front. So item 3 is at the front means front will always keep 0, but rear now becomes 3. So rear has 3 now, because item 6 now would be considered to be at subscript number 3. You can well see when item 3 is being deleted. Now which is at the front, which is at 0th subscript number? See, item 4 is at 0th subscript number. And the last one, that is item 6, where it is? Item 6 is at subscript number 2. So rear has to be changed to 2. So as a Python programmer, you need to understand how to change the thing, how rear should be updated, how rear should be changed. Then if item 5 is deleted, what would happen? Item 5 is in now 0th position. So what is the position of item 6? That is the item which is at the rear end. It is 1. Subscript number of item 6 is 1. So front is 0 and rear is 1. Now rear is 1 means you can well understand that when I delete item 5, what would happen? Now only single item is present. This single item which is present, it gets the 0th position. As this item is at the front now, this gets front is equal to 0, and as it is the only item, we will have to say that this particular item is at the rear also. So rear is also equal to 0. So at this moment, front is also 0, rear is also 0. But as this item is also deleted, then none are left in the list. Now this queue is empty. So as the queue is empty, a Python programmer should again make front to be none and rear also to be none. So I think you have understood how deletion is done from a queue. Deletion is always done from the front end, and the value of front and rear needs to be seen. We should maintain the status of front and rear. So displaying items of a queue. How we will display the items of a queue? The items of a queue can be displayed from front to rear. The item can be displayed from front to rear. How items can be displayed from front to rear? The items can be displayed from front to rear in the following way. Let us see. This is the item which has been displayed, but how it got displayed? See, we'll see this to understand. First, item number 1 was displayed. Then item number 2 is being displayed. Then item number 3 is being displayed. Then item number 4 is being displayed. Then item number 5 is being displayed. And we are displaying now item number 6. So what is the order of displaying? The order of displaying is from front to end. That is from first item to the last item. This is the order of displaying items in a queue. The first item in the queue, that is the item which is at 0th subscript number, would be displayed first. Then the item at the first subscript number would be displayed. Then item at the second subscript number would be displayed. This is the order of displaying. So the order of displaying is same as the order of deleting. So I think you have understood how list should be used for applying queue as a Python programmer. We can summarize. Insertion is done at the rear end. Deletion is done from the front. And displaying is also done from the front. Now, so we can well understand the order of deletion of items from the queue is opposite to the order of inserting the item in the queue. We all know Q is deleted from the front and Q takes value, that is, values are inserted in a queue at the rear end. So the order is different. Now, who left the queue first? The person who entered the queue first left the queue first. So who went into the queue first takes the ticket first and comes out first. So first in, and how he comes out? First out. So the person who enters first, that is, who is first in the queue, comes out of the queue first. So we say queue follows a policy. What is the policy that queue follows? FIFO policy. First in, first out policy. So if a Python programmer is asked what a queue is, so he will say that a queue is nothing but a linear data structure where elements are arranged one after the other. And which policy queue follows? Queue follows first in, first out policy. So what type of data structure is a queue? Queue is a FIFO data structure, first in, first out data structure. One more thing for queues to understand is, there is one more work which we can do with a queue, that is known as peek. Peek is nothing but inspecting a queue. Now, inspecting a queue means seeing a queue from the eyes of the staff in the ticket counter. So who he is going to see first? We all understand that he is going to see the first man standing in the queue first. So if Python programmer is said to implement peek function, he will display the value at the 0th subscript number. The other thing which we should understand is why we are reading queue. Because computer uses queue or takes the work of a queue in many given workings of the operating system. For example, if I am trying to print values and we are having one printer in a network, so maybe 5 people give the job of printing to the printer at the same time. But the printer is going to keep those jobs in a queue and complete that job one by one. Similarly, in real life, if you have a call center, the call center takes the call of the people as it comes. So the call is taken on a first come first serve basis. So it is nothing but a queue which is being maintained. So this is how queues are important in our life. And we should understand that Python also need to work with queues. And how Python implements, as I have already said, Python implements the queues with the help of lists. So let us go to Python and start making a queue for our use. So we'll now go to Python and we will make a queue for ourselves in Python. So let us go and let us make a queue in Python for ourselves. So we are here, we are trying to make a queue, and where we should be to make a queue, we should be at the script mode. That is, we started and we are trying to make a queue here. So what should we do to make a queue? Few things that should be done is, first is we'll have to make a variable called front. Let us make it. We'll make a variable called front. We'll keep none in front. We have already said we have to maintain these two variables, front and rear. We'll keep none in rear. Then we'll try to implement a function, say insert 5. Now where to insert? In a queue. So how this queue has to be implemented? I already said queue has to be maintained or implemented as a list. So queue is being implemented as a list. So I made a queue and this queue is nothing but a list. And I said I'll have to insert, and I have written a function called insert. I said call insert function, but did we define insert? Declare and define insert? No. So it is time now to define insert function. So we come here and we have started defining insert function. Now as insert function is going to work with global variable front and rear, so let us say front, global front and global rear. Now we want to insert. And we know that we have nothing in the queue first at this moment, that is queue is empty. So we'll have to check if queue is empty, what to do. As we have seen, if queue is empty, how we can check whether queue is empty or not? We can check whether queue is empty or not using len function. And what should we write? We should write queue. We have the list's name as queue. So we'll write if length of queue is equal to 0, that is nothing is in the queue. Another way of writing that was, if I could have written if queue, this is only in comment to show you how we could have written if queue is equal to empty list. So these both mean the same thing, but we have used this len because we want to use and check whether the queue is empty. So I can use this len function. Now as I came here, as queue is empty, now first value is going to be inserted in the queue. So when first value is going to be inserted in the queue, what should be done to front and rear? Front should be made 0 and rear should also be made 0. As I said that when one value comes in, both front and rear becomes 0. And did I keep a parameter? No, so I should be keeping a parameter also here. Whatever comes in n should go into the queue. So I have kept a parameter because 5 was being given, so parameter is required. Now else, so we'll have to write else. Else means what to do. Else means what to do if it is not the first value that is being inserted in this given queue. Maybe it is the second value, third value, fourth value. Then we all know if it is the second, the third, the fourth, we all know. That means what? That means we have to only increase rear. So what should rear be? Rear be equal to len of stack, because we know len of stack means one more than the last subscript number. If queue had one element, so len of stack would be 1. We know rear should be 1 for the second element being inserted. So I put len of stack as rear. So this work I have done, but have we really put something in the queue? No. So now our work would be to append a thing in the queue. So append what? So we append n. So our definition for insert has been completed. Now we also should define a function called display. Why to define the function called display? We want to define because whatever we inserted in the queue, we need to see it. So we would define a function called display. Here even also you can check whether something is there to display or not. See the habit, I'm writing stack, but what we should write here? We should write queue because this time we have taken a queue. Now if I want to display, we should be first seeing whether something is there or not. If something is not there, so nothing to display then. So nothing to display then means we'll write underflow situation, as we have learnt earlier also when we had the stack video. We saw the stack video, then we understood that if nothing is there in the list, we say it to be an underflow while working with data structures like stacks and queues. But if there is a thing, then we'll have to print the value whatever is there in that given queue. So how we'll print? We'll write the values in the queue are. And what we can do here, the values in the queue are, I put it here. And how can we print? We'll write for I in range. We have to print from front. So 0 to where? Len of stack. Again stack, see the habit. We should write len of queue. So we have written for I in range of 0 to. So it would start at 0 and go at len q minus 1. That is the last subscript number. And print the values there. How to print the value? We'll write q. And what I'll write here? I. So this is how things would be printed. And if we want to print in the same line, so I'll write end is equal to space. So I have written two functions here. One is for inserting and the other function is for displaying. Now while displaying, we need not change the value of front and rear. It is not required because we are not deleting an element or inserting an element while displaying. We are only displaying the elements. So now let us run this code. So we go to run the code. So when I run the code, I want a name to be given. So let us give a name Q5. I gave the name Q5. Nothing happened. Why nothing happened? Because insertion was done. But we have not written here the invoking of, that is calling of display function. Now I call display function also. So what do you think would be displayed? So as I use display function, what will happen? It will display the values in the queue are 5. So it displayed. Now let us write the delete function here. So we'll write the delete function. So we write delete function. What is the function delete? Delete is used for deleting an element from the queue. Here also we'll write global because changes have to be done in global variables front and rear. So we'll write global front, global rear. I'll write if. Why I'll write if len? If nothing is there to be deleted, then what we'll say under flow situation, if length of queue is equal to 0, then print underflow, else. See, if only one thing is left, then front and rear both has to be made what? Both has to be made none if it is to be deleted. So if length of queue is 1, then front should be none and rear should also be none. But if more than one thing is there, so what should be the value of front? Front would be as it is. We have seen while deleting. Only rear goes to 1 less than what rear has. So we can write rear is equal to rear minus 1. Okay. So that means rear gets one value less. And then we can print the items in the, what we can print? The items in our list are, what is the item in the list? What we have in the list. So we'll write here, but before writing, what we'll do? We have len q. We checked whether it is there or not. We said if rear is equal to rear minus 1, we have to make rear is equal to rear minus 1. No problem. Now what to do? We have to really delete something from the list. How will delete something from the list? We'll write print the item or value being deleted from the queue is, what is the value that is being deleted? How we delete? We write q.pop 0. So if I write q.pop 0, the item would be deleted. I want this line to be written after the display line. So I'll give a /n. You can give, you cannot give. That is you to decide. So this is what? This is delete. So let us now try to run the delete function. How it works, let us see. So we will have here something called two inserts we do first. Let us insert one more value. Say let us insert 7. So how many values would be inserted at this given moment? Two values would be inserted. One is 5 and the other one is 7. Now this will display 5 and 7. Now if I say delete, which value would be deleted? The first value would be deleted. Then if I display after delete, what would we be left with? We'll be left with 7. So if I run this, it says we have not given a colon here. So let us again run after colon. So name is insert is not defined. Maybe There is an error. Name insert is not defined. Where is name insert? Let us see. Name insert. See here. I should be capital. These errors come while we write the code. See here. The values in the queue are 5 and 7. But when we deleted, the value being deleted is 5. So the value which we are left is 7. So 7 is being displayed. So our function is working fine. Our delete function, our disp function, and our insert function. These three functions are working very fine. Let us go for the peek function. What should be written? For peek, we will write def peek. Okay. We should be writing it in small letters. So name of the function can be even in capital. Nothing to do here. We'll write print what? Q0. And you can give it a statement also here. The value being inspected is this Q0. So let us now try to run the peek function also. So this is where I'll write the peek function. Anywhere I can write the peek function after inserting 5. So I'll write peek. Let us see how peek works. See, the value being inserted is 5. Sorry, the value being inspected is 5. That is, peek is working, and it says the value that has been entered and now being inspected is 5. Then it says the values, because display is run after insert and peek. So the display part is working after peek. So the values in the queue are 5 and 7. The value being deleted, the delete function comes to work. 5 is being deleted. So what we are left with? We are left with 7. So all these functions are working well and implementing a queue using lists. Let us try to do one more thing. Let us try to run a display before inserting anything. So if I run a display before inserting anything, nothing is there in the queue. See, the queue is giving underflow because nothing is in the queue, and we said display. It is saying nothing is there, so it is giving an underflow. Now let us even delete the 7 and then see what is there in the queue. So how will delete the 7 also? We'll again write a delete function and then see what is there in the queue. So after 7 is deleted, again queue would be empty. So if I run this, what will happen? See, first underflow because nothing was there. 5 inserted, so peek worked and it inspected 5 because 5 is the front value, that is value at the front. Then values in the queue are 5 and 7. The value being deleted is 5. That is, now we are using the delete function to delete 5. The values in the queue is 7 now. The value being deleted again, delete function is being used, and so 7 is deleted. Now, after that, if you run display after deletion of 7, nothing is left, so underflow is being shown. So I think you all have understood how queue works. So queue works by applying the policy of first in, first out, that is FIFO policy. Queue is applied by our computer in many works. I talked of 2 works, the printer job scheduling, I talked of it, and then in real life also call centers work with the policy of queue, the ticket counter works with the policy of queue. So these are there. I think you have understood how queue is implemented in Python. That's all for today. Thank you very much.